Hello, ladies and gentlemen. Welcome back. Mr. Ellering here again. We're going to look at section 1.5. Section 1.5 is actually pretty short, but I am going to break it into two parts because we're doing just part of it on one day and we're going to do the other part on the second day. All right, so there's three strategies that we're going to use to solve some problems, okay, some problem solving strategies. Those three strategies are use a formula, look for a pattern, draw a diagram. In this video, I am going to talk only about the first two. Okay, this is the part one video. And in the next video, I'm going to talk about how to draw a diagram from the situation for that problem solving strategy. All right, here we go. Let's look at a formula. In this problem, we have a bus that is traveling at an average rate of 55 miles per hour. The distance between Chicago and San Francisco is 2,130 miles. And the question is, how long would it take for the bus to travel from Chicago to San Francisco? All right, well, let's see. We're talking about distance. We're talking about time. And we're talking about rate. Okay, so this sounds like it's the distance formula. And if you don't know a formula, okay, remember, there's the internet. You can put in some keywords in a search and you should be able to find those formulas. They should also be in your book somewhere if you go and look. You did a lot of formulas in geometry, so we're just going to do this one example, all right? So let's see, what do we know? Well, we know the rate is 55 miles per hour. All right, we know that the distance is 2,130 miles, and it's asking how long does it take, so that's the time. Now, what is the formula for this? It's simply distance equals rate times time. All right, so we plug in what we know. We know the distance, we know the rate, and we want to find how long does it take. All right, well, solve for the variable t. Okay, divide both sides by the 55. A simple one-step equation. And we put that into the calculator, and we're going to find out that it is 38.72. And that would be in hours. All right. Again, you did a lot of formulas in geometry, so you should be pretty good at that. All right, next, looking for a pattern. Now, I'm going to be specific with this pattern from intermediate algebra. Okay, hopefully you kind of recognize it. We've got an x value in a table and a y value in a table. All right, so I'm looking for a pattern, and then we're going to write an equation. So looks like in this problem, ladies and gentlemen, the x values are going up by 2. And it looks like the y values are going up by 4. Now, if you remember from intermediate algebra, we have that y equals mx plus b. Okay, remember, that's the linear equation. Whoa, there we go. The linear equation, straight line. And, whoops, I forgot the x. There we go. Y equals mx plus b. That's very important. Now, the slope, if you remember, okay, slope, is rise over run. And if you remember also that the rise is what's happening in the y values, and the run is what's happening in the x values. So if I look, the pattern for the y values is 4. So the rise is 4 and the run is 2. And that gives me 2. All right, now the b, remember, is your y-intercept. Okay, well, the y-intercept, ladies and gentlemen, what's the x value of the y-intercept? The x value is always 0, right? Well, I see right here, ladies and gentlemen, that I've got an x value of 0 right here. So the y-intercept is 5. So in this situation, the y-intercept is 5. So I have my values now. So I can write my equation, y equals 2x plus 5. All right, let's do one more example of this. All right, so I'm going to look at my x values. I need to make sure they are consistent with going up, and so that I can use my slope. So let's see, we've got a rise of, it looks like 3, another rise of 3, and so on. Here it looks like a rise of 2. Okay, what I mean by rise here is that the numbers are going up by 2. I'm not talking about slope yet. So the x values are going up by 3 and the y values are going up by 2. Now I can talk about my slope, rise over run. Okay, hopefully I didn't confuse you when I said rise just a little bit ago. So here the rise is the y value, remember. What's the y value going up by? That's 2. The x values are going up by 3, that's the run. So in this situation, it's 2/3. Now, what about the y-intercept? Okay, I notice, ladies and gentlemen, that there's no 0. Okay, remember, I want to know what the partner is when x is 0. Well, that's not in the table. Now, there is a way to do this algebraically, but I'm not going to talk about that today. I'm going to just talk about the pattern, okay? So what I'm going to do is I'm going to go backwards, all right? I'm going to go backwards. So I'm going to go backwards. So on the top, I'm going to go backwards 3 until I get to 0. So I'm going to count backwards. So I'm going to go 6, 3, 0. Okay, I went backwards in the top, the x values. Now the y values, I'm also going to go backwards. So instead of going up 2, I'm going to go down 2. All right, so I'm going to go 0, and then I'm going to go -2, and then I'm going to go -4. So ladies and gentlemen, there's my y-intercept. So now I can write my equation, y equals 2/3 x minus 4. All right, that's it for this part of the video, ladies and gentlemen. Again, you have the power of pause and rewind. If you need to go back and rewatch anything, please feel free. All right, after you're done with this one, you can go ahead and work on your book work, etc. Remember, we're doing the worksheets in class together. Okay.